Welcome to Stallcup's Hot Topics. We answered the questions pertaining to this section in our question and answer section of Stallcup, but the subject today will be 210.8F. And the only reason that we're including this in Hot Topics is, well, we've had so many questions still coming in pertaining to exactly what does 210.8F require. Now, before we really get into any of this, I would like to point out that we're not here to talk about anybody's interpretation of the rules or anything like that. We're just going through sections and the definitions that might be helpful in you or anyone else, getting in and making an interpretation of this rule. Now, first of all, I'd like to go, if you will, if you have your code books handy, let's go over to page 38 in your code book. And on the right-hand side of the page, let's take a look at the definition of an outlet. This seems to be the big question. What is an outlet? And this particular definition is causing a lot of different interpretations in the field. Now notice the definition of an outlet is basically a point on the wiring system at which current is taken to supply utilization equipment. Now, next I would like to review the definition of utilization equipment, and let's just go over to page 41 of the NEC. And on page 41, let's review on the right-hand side of page 41 of the NEC, right at the very top, the definition of utilization equipment. And it basically states that equipment that utilizes electrical energy for electronic, electromechanical, chemical, heating, lighting, or similar purposes. Now, the next definition, let's go over and read the definition of appliance on page 32. So let's just back up to page 32 in your code book. And we want to review the definition of an appliance on page 32, left-hand side of the page at the very bottom. And basically, appliance is defined as utilization equipment, generally other than industrial, that is normally built-in, standardized sizes or types, and is installed or connected as a unit to perform one or more functions such as clothing, air conditioning, food mixing, deep frying, and so forth. Now, I believe the next thing that we should probably review then would be an enclosure, because it seems like folks are saying, well, an enclosure could be an outlet point where you would receive the power, where it's a controller, a disconnect, or whatever that it may be. So let's go to page 35, if you will, with me, please. And on page 35, we would have on the right-hand side of the page at the very top, enclosure. And notice it says it's a case or a housing of apparatus or the fence or walls that might surround an installation to prevent personnel from accidentally contacting energized parts or to protect the equipment from physical damage. Now, that's what an enclosure is. It guards the electrical wiring that might be exposed or electrical components, so to speak. Now, so we've looked at that definition. Now, the other thing that becomes an issue with providing this GFCI protection is a disconnect. is a disconnect considered an outlet? And so we want to review now the definition of a disconnect on page 34. So on the right-hand side of page 34, we pick up the definition of a disconnect, and it reads, a device or group of devices are other means by which the conductors of a circuit can be disconnected from the other source of power or energy. So a disconnect, to me, it disconnects something to work on or to service, repair, or whatever the job task may require. Now, the next thing that I think is important is to take a look at, say, a branch circuit individual or say branch circuit appliance. We want to review that. So in doing so, let's go to page 33. Page 33 of your NEC. And on page 33, left-hand side of the page in that first column, we pick up an individual branch circuit individual. And it reads, a branch circuit that supplies only one utilization equipment, such as an air conditioner, heating unit, a sign, whatever it may be saying. Now, the next, I think, important definition for you that has a responsibility, to interpret this section, branch circuit appliance. Same page, page 33, right on the left-hand side of the page in the first column. A branch circuit that supplies energy to one or more outlets to which appliances are to be connected and that has no permanent connected luminaires that are not part of an appliance. So that's basically the definition there that we need to review, I think. And then, of course, the disconnect itself on page 34. Now, going over to page 34, we want to look at the definition of a disconnect. And on page 34, we pick that up on the right-hand side of the page down toward the bottom of the page. And under the title head, disconnecting means it's defined as a device or group of devices or other systems by which the conductors of a circuit can be disconnected from their source of power. Now, would that be considered an outlet or would it be considered a disconnect to disconnect power to the source? See, that would be an important definition there to read. Then I think the next thing that section we should look at is 110.22a as in Apple. So let's go to page 49 of your code book. And on page 49 of your code book, right-hand side of the page up toward the top, we pick up 110.22a. Now, starting with the definition, it says identification of a disconnecting means. And then A is general rules. And it says each disconnect shall be legibly marked to indicate its purpose unless located and arranged so markings shall include the identification of the circuit and shall be sufficient durability to withstand the environment. So they're just saying, like 408.4 for a circuit mapping label. The disconnect should identify what it disconnects. And of course, a lot of inspectors says, well, if it's evident that it disconnects it, then okay. So this is an Inspector 90.4 decision that we naturally would have to make sure that we obtain if we're installing an installation in accordance to 210.8F. We would make sure that we would do that. Now, the other thing that becomes an issue, they talk about a controller. And a controller and an enclosure at the air conditioner unit will you terminate this branch circuit that we disconnect in 110.22a when we use a disconnect? Is that considered an outlet, or is that just a termination point? It's, again, it's it's an interpretation of what one considers is an outlet. See, so now if we go to page 34, and if you'll turn to page 34 with me, if you have your code book handy, or maybe you're just listening, and we go over to this definition of a controller that we want to look at. So on the right-hand side of the page at the top, we pick up under the title head controller. It's defined as a device or group of devices that serves to govern some predetermined manner the electrical power delivered to the apparatus to which it is connected. Now, apparatus to which it is connected. It really doesn't say outlet. So we have given you a number of definitions that is very important to make this determination and to make a interpretation of this rule according to the design installation of 210.8F. Now, right now, I believe there are two things that you really need to look at. What does the authority having jurisdiction say? What is their interpretation in accordance with 90.4 in Article 100? Or maybe there is a state amendment, county or city amendment to the NEC in relation to 210.8F that revises it and says, no, it's just a disconnect. Maybe no, we consider it an outlet. But to me, ground fault protection of electrical equipment maybe should be used here, where you'd have a Class B 30 or 50 milliamp ground fault protection of equipment device, not a GFCI that creates a lot of nuisance tripping for the user of this equipment. And of course, we can get the definitions of GFCIs and ground fault protection of equipment. Now we go to page 36, if you want to do that, and kind of wrapping this up, bringing it to an end. And when we look at GFCI protection, then we're on the right-hand side of page 36, right at the very top, and the title is Ground Fault Protection according to GFCI, and it states that it's a device that is intended for the protection of personnel, not equipment now, but personnel, and the functions to de-energize a circuit portion thereof within an established period of time when a ground fault current exceeds the values established for a Class A device. And usually, that's about 6 milliamps, give or take one. It could be say 5, it could be 6, it could be 4, that kind of thing. But they're designed to trip no greater value than 6 milliamps. Now, it tells you that in the informational note to ground fault protection for personnel, GFCI. Now we go down on the same page, down to ground fault protection of equipment. Now notice it's a system intended to provide protection of equipment from damaging line to ground fault currents by operating to cause a disconnecting means to open all ungrounded conductors of the faulted circuit. The protection is provided a current to protect against current levels less than those required to protect conductors from damage through the operation of a supply circuit overcurrent device. Now, these devices, overcurrent devices, circuit breakers, you can purchase those with ground fault protection, short circuit protection, GFCI protection, AFCI protection. But when you want to protect for the ground fault protection of the equipment, then you use naturally the Class B, which I believe now is 30 milliamps up to 50 milliamps to protect the equipment. What bothers me about this rule, 50 amp or less GFCI protected devices. But if you're over 50, like a 60, then it seems to say that, well, that's not as dangerous. Is that because maybe more 50 amp overcurrent devices are used in 60 in some of these units? Is that what that's based on? But again, I'm not knocking anybody's interpretation of this rule. I just think that the code panel should look at this and change it to ground fault protection of the equipment. And I think if the equipment malfunctions, it's going to open it up and basically provide the same protections except for leakage type current that might occur. So we'll just see how this comes out, but it's a 90.4 installation, and that's what's important to check with the authority having jurisdiction to get their interpretation before you make such an installation, and I think you'll be on safe grounds. And now we would like to just look at some illustrations here, basically 3, and maybe tie this hot topics together so that you can review everything and see just exactly what would be your interpretation of the rule. Now notice the purpose of the change in the first illustration, which is outdoor outlets 210.8F of the NEC, which is basically on page 63 of the NEC. And notice to the left, toward the bottom, right above the purpose of change, we have a receptacle there shown as 15 or 20 amp, 120 volt, but no more than 150 volts to ground, and it shows that receptacle. Then the one to the right, toward the bottom, we show the 240 volt, no more than 150 volts to ground, and we show it 50 amps or less. Now, I kind of always thought that this was talking about outdoor outlets, but it seems that we do have some different interpretations of the rule. And again, we're not knocking anybody's interpretation. We're just throwing some information out on this section 210.8F and see what you think about it. But notice the purpose of the change. If you wanted to get a lot of this information from our code change book, and then actually it's Stallcup's illustrated code change book. Just go on our website and you just type in James G. Stallcup and it'll come up, and you could get one of these if you're interested. Now notice another thing that's an issue if you review the illustration. Right up at the very top in the eave of the dwelling, we show where these receptacles do not have to be GFCI protected. They only have to have protection for ground fault protection of equipment, like a Class B type circuit breaker. And those sections, which we won't review, you can do it independently if you want to, but 426.28, 427.22, and of course, the permission to install these receptacles for these conditions of use would be 210.8, A as in apple 3, the exception to 3. Now, this kind of just shows the outdoor receptacles being GFCI protected, so to speak. Now, moving to the next illustration, then we show an illustration from Stallcup's design book, and it's 440.63, and it's what could be used as a disconnecting means should you cord and plug connect. Now, notice we show in the illustration the overcurrent protection device at the service equipment routed over to this receptacle, and it's cord and plug connected. Now, I suggest that you review 300.15A3, and that'd be approximately on page 146. Look at 300.18a, and that'd be approximately on page 147, and review that information there. And then to cap it off, read 314.1, which deals with items that could be used as an outlet. And you notice a conductor is not mentioned there at all, but it goes through a complete installation up to the time you pull the conductors and terminate those conductors at that receptacle or disconnect or at, say, an AC unit. Now notice this is card and plug connected and gives you the rules, and notice that attachment cap can be used as a disconnecting means in relationship to the receptacle. You don't lock and tag out that receptacle by Article 120 of the NEC, because you have the attachment cap and complete control of your job task, whatever that it may be. And then you notice, just for additional information in the illustration, we show you overcurrent devices are readily accessible in 240.24a that you would review. And then the overcurrent protection height, maximum height, 404.8a. And then, of course, where you have an exception to that rule would be 404.8a exception number 2. Now, that's some information and sections you review if you wanted to do a more case study in relationship to this illustration we're looking at, titled Disconnecting Means 440.63. Now, the next illustration that I want to go over with you is location of a disconnect that is located outside by the AC unit, and that's 440.14 of the NEC, and the illustration that we're reviewing comes from Stallcup's Design Book, Volume 2. Now notice we give you the location of the disconnect, where it could be located, where it may not be within sight of the unit under the exception 1 to 440.14. But again, notice from the service equipment inside, we have the overcurrent device, and of course you know that that would be sized to allow the unit to start and run by 440.22a of the code. And you have your conduit run to the disconnect and to either, say, a permanently installed type connection with conduit, or maybe flexible cable, weatherproof type cable that we would use. But notice again, to understand this part of it, we've already looked at definitions pertaining to the disconnect. We reviewed a disconnecting means as it is defined in Article 100 previously. We also reviewed 110.22a that kind of dealt with this disconnect. And then if you'll notice, the conduit run, the pigtail that we may use here, or a whip, whatever you want to call it. Notice, though, that we would review again 300.15a as in apple on page 146 of the NEC. Then review 300.18a, which is on page 147, I believe, of the NEC. And then review 314.1 on page 182 of the NEC. Now we don't go through those sections, but we give you the sections, the page numbers, and it's easy for you to review that in your code book. But we're just we've gone over the definitions with you. We've showed you this disconnecting means in the illustration. And if you notice, some people say, well, that's an outlet. They'll go to the unit, and remember we reviewed an enclosure that enclosed the controller and so forth. But notice the conductors are routed through the disconnecting means and then to the AC unit, and then they are terminated. So there's nowhere in the code that I can find that a conductor, its termination in, is considered an outlet. Now, I don't believe, in my opinion, that that's what this new NEC 210.8F section's about. But again, everybody has an interpretation. And I will close this out by simply saying, before you as an electrician make this type of installation, find out where the authority having jurisdiction considers the outlet is, or where just a disconnect is, or what is an enclosure, and you have those defined so that you can go over them and maybe serve as a great aid to you to make a decent interpretation of this rule. Good luck, and in closing, may the good Lord take good care of you as He has me, and again, may the good Lord take a liking to all of us.